In this video, we demonstrate the most important applications of the TrainOptimizer software using a complete example. To begin, you must go to the home page and log in. After logging in, you will see a project list. This project list contains existing projects, which you can edit here using the pencil icon. You can access the projects to create the corresponding carriages. You can form trains or delete a project from the list. We will now create a new project. If you want to create a new project, go to Add New Project. In the next step, select a project name, which will then be displayed on all slides and charts. For the demonstration example, we choose the name Intercity 2, IC2, and can add a more detailed description here for internal project identification purposes. In the next step, you have the option of selecting the type of transport. Here, we can distinguish between long-distance transport, regional public transport, and urban public transport. These modes of transport are important because they allow the software to assign the basic behavior of travelers accordingly. Since we are planning an intercity train in the example, we now select the mode long-distance transport. In addition, you have the option of selecting different regions or data from operators. Some of this data is available in the basic package. It is also possible to collect data from your region or for your operators separately and import it here at any time. For this project, we select the general dataset, which covers the behavior of travelers in Central Europe very well. The project is now complete and we can confirm this by clicking Save. However, it is also possible to make further settings under Advanced Settings. The following settings are available. There are different categories of travelers' willingness to stow luggage, particularly with regard to lifting luggage. It makes sense to leave the category set to default in this project. With default, the appropriate default values are also assigned for each selected travel class, for example first class or second class. The default values include comfort, which are values that make sense in the first class range, as they take into account how many travelers do not want to lift their luggage. The standard category is selected for second class. Standard includes those categories in which travelers are still willing to lift their luggage under certain circumstances. Limit is the threshold value that travelers only meet when there is no other option. It is therefore recommended to select comfort for first class and standard for second class. If you leave the default setting, these values will be taken into account by default. You can also select different seat capacities and standing room capacities in the advanced settings. Here you can define how many people you want to calculate for boarding or deboarding. You can also define different standing room capacities in the entrance area, in multipurpose areas or in the aisle. Since we have selected long-distance transport as the transport mode for this project, no standing room capacity is assumed by default. This means that the system assumes 0 persons per square meter for standing room. However, if you want to include standing passengers in your calculations, you can enter the corresponding modified values here. You can also change the age and gender distribution. Here you can see an average distribution of passengers, broken down by gender and different age categories. You can change this distribution yourself, but you must always check that the total sum is 100. We have not made any changes at this point. In any case, it is advisable to always keep the default value or the set default values. We now click on Save to create the project. The project IC2, Intercity Train 2, is created here with a new date. In the next step, we go to the carriages and want to create a new carriage. In an existing project, you would find the carriages that have already been created here in the carriage list. We have not yet created a carriage, so we define a new carriage here. To do this, we click on Add New Carriage. We now define a new carriage and assign it a name, which will ultimately also be used in the evaluations. In this case, we call the carriage Second Class Standard. The carriage description again offers the option of providing more detailed information for internal purposes. For example, Second Class Standard. The next step is to specify the internal dimensions of the carriage. This does not refer to the length over buffers or other external dimensions, but to the dimensions that are actually available in the interior. Please note that the dimensions must be entered in millimeters. Here, we choose a length of 25.5 meters and an internal width of 2.70 meters. In the next step, you can define whether it is a single-deck or double-deck vehicle. In the next step, you can define which class this vehicle should be assigned to. You can decide whether there are several areas of different classes in the vehicle or whether the entire vehicle remains assigned to one class. We will now assign a class to the vehicle and stick with second class. For first class, you would click on First Class. For classes such as business class or generally higher classes, you can also specify First Class Plus. You also have the option of defining night trains, such as couchette cars or sleeping cars. However, you can also select a dining car or, if you are planning underground vehicles, for example, select urban transport. We will stick with second class for this project. Alternatively, if you want to select two different areas in a carriage, you can specify that the first 10 meters of the carriage belong to first class. We add another section and specify that the section up to the end is now assigned to second class. To undo these settings, you can delete the areas here or switch back to single, for example select a single area for the entire vehicle. Once the class has been selected, you must click on Save Class Configuration. This will turn the Save button at the bottom right orange and you will now be able to save the vehicle or the specific carriage. Please note, once this carriage has been saved, it cannot be edited afterwards. You can only create new carriages. The main reason for this is that the dimensions cannot be changed afterwards, as they would no longer match the layouts you have already created at a later date. You will now see in the carriage list that a carriage is already present, namely the one you have created. You could also define additional carriages here, such as a first-class carriage or a restaurant carriage. Here, you also have the option of switching between projects. We will now stay with this project and define layouts for this carriage. To do this, we go to the layout list. Existing layouts are also listed here. However, we are starting with a newly created carriage. Therefore, there are no different layouts yet. We can now create a new layout. We will call this layout Variant 01. Please note that this abbreviation will also be used in the evaluations on the charts. Therefore, it makes sense to choose names that are as short as possible in order to maintain a good overview in the evaluation charts. The layout is now defined by clicking Save. You can delete the layout or the specific layout again by clicking X. We can now edit the layout using the pencil icon. Here you can see the floor plan of the layout. A carriage body that is currently still completely empty. You can now edit it using the following functions. We have a toolbox here where you will find a wide variety of items that are already pre-configured. However, you can edit most of these elements yourself. For this purpose, you will find different types of seats, here classic for long-distance travel. Seats that have their own storage compartments between the backrests, but not to be confused with classic luggage racks. We have elements such as a bench seat or a corner element for a bench seat. Tables that are arranged so that luggage can be stored underneath them. We have luggage racks, luggage areas on the floor, overhead storage compartments, aisle areas, multipurpose areas, partitions in the vehicle and doors in the vehicle, for example areas that are generally unusable. This refers to an area that cannot be used by passengers in the classic sense, neither for sitting or moving around, nor for storing luggage. These areas can be used for the design of toilets, galleys, electrical boxes, and the like. We have various elements here for stairs, which can be relevant on the lower deck, especially in areas where they lead from a low-floor area to a mid-floor area. There are also steps that lead directly to the upper deck on double-decker trains. We have two types of folding seats here, a folded-up folding seat and a folded-down folding seat. This has a capacity of one person. We have separate seats for urban transport. We have entrance doors, wheelchair lifts, any elements in the entrance area, carriage transitions, and beds for night trains. We can also move the toolbox to the side by clicking on the luggage symbol. Here we have the option of switching between different layouts. This is currently our first layout in this example, so there are no others to choose from. For double-decker trains, you could switch between the lower deck, Deck 1, and the upper deck, Deck 2. To define overhead storage compartments, switch from the floor layer to the ceiling layer. We will now remain in the floor layer so that we can arrange seats, aisles, tables, and the like. Here you have the option to save your work in between. It is recommended that you save regularly. Here you can save a layout under a different name. As with other software products, this allows you to easily edit an existing layout at a later stage and thus generate a new layout. On the right-hand side, we have the following options. You can load a background image here. This has the advantage that existing design plans, which are available as image files, can be displayed. This allows you to quickly replicate any seats and other fixtures in the vehicle without having to take exact measurements. You can hide this image, the background image, here. You can also select the opacity here. If you have defined a vehicle with different class areas, you could display these different class areas. In this project, the entire vehicle is assigned to second class, so there is only one area that is displayed in green. To make it easy to recognize which area you are in, for example, if there are several classes, this is helpful so that you do not position items such as seats exactly on the class boundary. This tool offers the option of taking measurements. To do this, we need to activate the measuring tool once. You also have the option of introducing snapping, which allows you to snap to existing items when taking measurements, for example, snap directly to a boundary. You can also take approximate measurements here and have the option of taking diagonal measurements. To delete the measured points you have drawn in, simply click on Delete All Measurements. Once you have finished measuring, you can deactivate the measuring tool again. Here you will find a wide range of settings for the items, where you can configure dimensions and similar. We will look at this in the next steps. To control the layout or create graphics, there are various functions that you can use with the keyboard and mouse. For example, you can simply scroll up and down with the mouse wheel. You can zoom in and out on your layout by pressing the Control key and turning the mouse wheel. If you press Ctrl and Alt simultaneously and move the mouse wheel, you can move the graphic to the left and right. Let's now start creating a classic passenger coach. In the left-hand area, we start with a gangway connection. Here you can see the various setting options. You can select the depth of the transition or the width of the transition. For example, we can select 1500 mm here, and the transition itself would be 400 mm long per carriage end. In the next step, you can select the element again by clicking on it. When it is orange, the element is selected. This applies to all elements. If you now click on the element with the left mouse button and hold it down, you can move it. If you press the space bar at the same time, you can snap it to existing elements. This is called snapping. Here, in this specific case, we would snap to the outer skin of the vehicle or to the boundary area to the interior. The black contours you see here symbolize the dimensions of the interior. In the next step, we insert doors using single-sash doors. You can insert the element by clicking on it once in the list and then clicking on your editing area. We also have various setting options here. We can say that the door width that is pre-selected is 900 mm. We can also specify that the door should be 1000 mm wide. We can give the door a name, as this door name will be displayed in all evaluations. It therefore makes sense to overwrite the generic name with your own. As with all elements, we now also have the option of specifying a distance for snapping to the next elements. For example, we want the door to be positioned 25 cm from the inner wall. Therefore, we enter 250 mm for margin left, a distance to the left side. You do not need to click Enter and can simply click anywhere. We click on the door until it turns orange again and can now snap. To do this, press and hold the space bar again, snap to the wall, and now you will also see the snap area as a blue line on the left-hand side. We configure the door via Advanced Properties and specify that this is a classic intercity carriage. It has 3 steps. The number of steps refers to the number of steps from the platform to the interior of the carriage. Here you can select the number of steps. This affects the passenger changeover time. Depending on the platform height in your network, you will probably select 1, 2, or 3 steps, or 0 steps for level boarding. For older vehicles or low platforms, you can also select for steps. For example, let's assume a platform that is 55 centimeters above the top of the rail. Here, 3 steps must be climbed to enter the vehicle. It only makes sense to click on gap bridging if level boarding is actually available, because that is where you will notice a difference, as level boarding reduces passenger boarding time thanks to a gap bridging system. There is another value here that you can overwrite. Since the entry area does not need to be specifically configured as such, but is automatically recognized by the system, you have the option here to change the number of people in the entry area. If, for example, you want to deviate from the default setting, you can enter a different number of passengers here. For example, it would make sense if you have a regional train vehicle in which standing room is normally provided, but you do not want to have standing passengers at the door leading to first class. In this case, you can overwrite the default value. In this case, in the long-distance train, we do not have any standing passengers. Therefore, the default values are set to 0 people and it is not necessary to overwrite the default value. Now we come to another useful function, copying an element. Click on the element to select it and turn it orange. Then press Ctrl and C. The element is now copied. If the element now lights up red, this is only an indication that there is a collision somewhere. In this case, there is a collision between the door and the outer skin or inner wall of the vehicle because copying places the object immediately adjacent to it. This should not cause us any further concern. You now have the option of selecting the element again by clicking on it, dragging it down, pressing the space bar again and using the preset distance to the left. Copying also transfers all settings in the advanced properties, such as the number of steps or the previously configured distance to the left. It is important to give the door its own name in this case as well. Using Ctrl and Alt and the mouse wheel, you can now move the layout to the left. Adjacent to the entrance door, we will now configure the toilet. For the toilets, we choose 2 at the end of the carriage. We use the item, unusable space. To do this, we click on the element, then on the workspace, and we have a pre-configured element for the unusable space. We now adjust the size and specify that the toilet has a width of 1000 mm and a length of 1400 mm. We also want to achieve a distance of 25 cm between the door and the toilet, and to do this we can define for this element that the distance to the left should be 250 mm, for example enter margin left. Now we click on the element until it is white, and again until it is selected and orange. You can see here that the element turns red in the collision area and remains orange outside it when selected. Press the space bar again to snap the object into place. To make a copy, press Ctrl and C to create a copy. Select the element and paste it on the other side. We have now inserted the toilets. In the next step, we select the seats. To do this, we select the double seat variant for the second class. We select this element on the left, click in the workspace and can edit the seat. We specify that the seat should have a width of 1070 mm, 107 cm for the entire double seat. The length from the rear edge of the backrest to the front edge of the seat should be 650 mm, for example, but can also be adjusted as desired. In the next step, we configure the seat by entering the dimensions we know. If we do not enter any dimensions, the values remain at -1. This means that the existing standard dimensions from before are used. Since seat backrests often have a slope, especially on long-distance trains, which can be used to store luggage behind them, we can configure different dimensions here. Dimension W1 for the entire seat corresponds to the dimension from the floor plan and cannot be changed here. This change can only be made in the floor plan data. W2 is a measurement at a height of approximately 850 mm. We can say that here the seat has a measurement of 620 mm. In the next step, we define W3 at a height of 600 mm, for example with a dimension of 520 mm. Then we specify the actual seat depth available, for example 450 mm, and a usable height under the seat of 300 mm. Luggage could potentially be stored here. We also specify that this seat has a floor support. If it were a cantilever seat, it would not have floor support. Now this seat is fully defined. We can push the seat directly against the wall and snap it back into place by pressing the space bar again. To quickly insert additional seats, we press Ctrl and C to copy, select this seat and then specify a predefined distance to the adjacent seats, the so-called seat divider. In this case, we say that the seat has a dimension of 650 mm, and we add another 250 mm. This results in a seat divider of 900 mm. This makes it easy to insert seats at the correct distance. Now all you need to do is press Ctrl and C each time the seat is selected, press the space bar to snap it, and you're done. Ctrl and C, space bar, snap. You can do this as often as you need seats in the same direction and with the same type of equipment. It is important to note that it is not absolutely necessary to map the layout with millimeter precision. It is sufficient to use approximate measurements. Of course, you are free to specify exact measurements, especially if you are importing planning data in the background. However, the exact dimensions are irrelevant for the actual task of the software, for example calculating passenger changeover time, luggage capacity and seat usability. Variations of a few centimeters can be accepted here, as they have no effect on the calculations. The situation is different with a deviation in aisle width, which does have an impact. This note is intended to ensure that you can create layouts quickly and still with approximately 95% accuracy. We will now continue and insert a vis-a-vis seat. To do this, we click on a seat again. Select it with Ctrl and C. Move the copied seat to the side and then right-click to rotate the element by 90 degrees. In this case, we want to get a greater distance than 250 mm to the left and enter a distance of 700 mm, for example. We now want to insert a table between the seats. To do this, we select the table element. To center the table, we also enter a distance of 100 mm. The length of the table to the front edge or the width of the table can also be adjusted individually if required. In this example, we leave the dimensions as specified and can place the table using the space bar. It is also possible to change the table sizes and create small side tables, for example. To do this, you would simply need to adjust the length from 1000 mm to 250 mm. In our specific example, we will stick with a table that can also be used for working. It is advisable to save the layout you have created so far from time to time. When you save, the system automatically switches to the overall overview of your layout. This allows you to check your current position in the entire carriage. We will now design a vehicle that, contrary to the basic recommendations, is geared towards maximizing the number of seats. This means that, apart from overhead storage compartments, we will not be planning any explicit luggage racks. At a later stage, however, we will draw variants that do include luggage racks. Now we can arrange the seats in the same orientation to the left. To do this, we can either select a seat, copy it and adjust the spacing again, or we can select another seat that already has this spacing. We copy this. Right-click twice to change the direction, and the spacing is already applied. In the same step, we add more seats. It is advisable to save again in between. Then we continue with the construction of the seats. To do this, we select a seat, create a copy with Ctrl and C, and change the direction of the seat by right-clicking. This allows us to duplicate the seat again using Ctrl and C. Now we want to arrange another vis-a-vis seat. To do this, we can zoom out, move to the right and select this seat, for example, as the distances are already pre-configured here. We drag the seat to the desired position, zoom in and arrange it accordingly. For the remaining seats, we can again take a seat from the left at the desired distance, where the distances are already configured. We can snap these seats again at a distance of 250 mm. Now we reach the end of the carriage and have to provide another entrance door here. For this purpose, it is possible to select an existing door. In this case, we set a distance of 250 mm to the right-hand side. We then insert this door using Shift and the set distance of 250 mm. We assign the door the designation Door 3. The other settings remain as before, for example the 3 previously selected entry steps. We copy the same door and insert it on the underside as well. Here, we assign the door the designation Door 4. Now we would like to insert a table as well. To do this, we can use an existing, appropriately configured element that already contains the necessary distances. Now we take advantage of the fact that millimeter-precise planning is not necessary, but that a representation that is as accurate as possible is sufficient. To do this, we can copy the seats downwards. We select all seats, press Ctrl and C, then select the copied elements again, and move them downwards. Due to the multiple selection of elements, exact snapping is not possible, as elements can also be offset and it is therefore not clear exactly which element you want to snap to. We therefore take advantage of the fact that we do not have to draw with millimeter precision and can still place the seats with sufficient accuracy. Next, we just need to make sure to rotate the table, for example, so that the direction is correct. This is done by right-clicking before snapping the element back down. Now we can save again. If all elements have been drawn correctly, the red areas indicating possible collisions will disappear. It can happen that collisions are displayed at a high zoom level even though there are none. By clicking the Save button, you can return the layout to its original state. If elements are still marked in red after this, collisions are actually present. In this case, you must move the relevant seats or elements slightly. It is now also important to insert the aisle element. In principle, the program is able to evaluate the distance here, but in order to allow you to plan the layout without having to be precise to the millimeter and thus make faster progress with the design, you can define the aisle separately, with the width that you assume to be the standard dimension. For example, the aisle begins here, directly after the toilets. You also have the option of drawing in another door for the interior area. To draw the door as accurately as possible, we use the measuring tool again and activate the snapping function when measuring. We can now record this measurement and see, for example, 687 millimeters. It is sufficient to then draw the door approximately to this scale and set the door width to 680 millimeters. Now we select the door and insert it accordingly. We can also place the same door on the other side. To do this, we select it again, copy with Ctrl and C, move it upwards, reduce the view, take the copied door and first place it in the desired position. At the other end of the carriage, it probably makes sense to draw in walls. To do this, we use the partition wall element to create a boundary to the entrance area. We can either change the dimensions of the wall or leave them unchanged. In this case, we leave them unchanged and specify that the wall has a length of 1 meter. Then we insert the door again between the walls as appropriate. As you can see, editing elements that are very close together can result in collision flags being generated again. In this case, it makes sense to click Save again. This will reset the view to its original state. Now we want to insert a corridor. To dimension it correctly from the outset, we use the measuring tool again. Measure the distance from one door to the other and determine that the corridor is 21 meters long. Here, too, we do not need to specify the measurement down to the millimeter. However, if you are planning for regional or urban transport, it makes sense to draw the aisles as accurately as possible, as the standing room capacity is also calculated using the element aisles. In long-distance transport, on the other hand, where no standing room capacity is provided, the aisle element merely serves as a basis for the tool to recognize where and in which direction people move to get to their seats. This is relevant for calculating passenger changeover time. Now we draw an aisle with a length of 21 meters. To do this, we select the aisle element from the item list, insert it, click on it and specify the length as 21,000 millimeters. We can also define the aisle width. To do this, it is advisable to check again how much width is available. This width is usually defined by the data that you use as a basis anyway. Here we see that the aisle width is 53 centimeters. This indicates a standard aisle of just under 50 centimeters, which is very narrow, but complies with standards. We now define the aisle width as 51 centimeters and insert the aisle accordingly. This completes the basic configuration of the carriage. All we need to do now is position a carriage transition at the other end. Before we copy the carriage transition, let's take another look at its advanced properties. There are various settings here. On the one hand, the internal dimensions of the carriage transition. This is particularly relevant for regional rail vehicles or urban transport, as these transitions can often also be used as standing areas. Both the exact length and the available width inside are important here. You also have the option of defining whether a carriage transition door opens automatically, for example, by means of a light barrier, or whether it is opened by default, as is often the case with regional rail vehicles or underground transport. In underground transport, there are often no doors at all. In this case, a fictitious door is considered to be open by default. Alternatively, the door can also be opened manually, for example, by pressing a button. This setting has a significant influence on passenger boarding behavior. We leave the setting at automatic opening, which is the default setting. This means that the door opens automatically when approached, similar to the existing open door. We now select the carriage transition, copy it with Ctrl and C, and paste the same transition on the opposite side of the carriage. In the next step, we add overhead racks on both sides of the carriage body. To do this, we switch to the ceiling layer. Only the overhead bin element is available here. We can define the overhead rack itself using parameters such as height, distance from the floor and available height to the ceiling, for example the so-called filling height. We can leave these dimensions unchanged for now. We can still adjust the depth of the overhead shelf here. For example, we select a length of 550 mm, while the width can vary. It is also possible to draw a continuous overhead shelf across the entire length of the carriage. Alternatively, you can also draw in several sub-elements. Here, too, there is the option of snapping. The object is aligned with existing elements. The overhead storage compartment can also be copied, rotated by right-clicking and then inserted. We can now see the inserted overhead storage compartment in the ceiling view. The arrow indicates the direction from which luggage can be inserted. Now we want to create a second layout in which the luggage storage is improved. To do this, we can remove individual seats and insert luggage racks. We now save this variant as variant 2. Designate it as our new layout and then switch directly to it so that we can edit it. To do this, we switch back to the floor layer and define storage points for the luggage. For example, we can remove one seat, rotate another seat, and adjust the distance to 700 mm, as with the other seats, whereby we need the distance to the right here. Then we reinsert the seat. The space that has been freed up can now be used for luggage storage. From a technical point of view, however, it should be noted that this distance is likely to be too small for a reasonable luggage size. For example, we only have 700 mm available here. It is therefore advisable to remove a second seat. We then move the seating area to the right. Here you can also see the option of snapping to other elements, in this specific case, oriented to the upper seats or, as now planned, with a distance of 700 mm to the right. Now we have a reasonable size for a luggage rack and can take another measurement. The measured size is 1600 mm, so we can insert a luggage rack of, for example, 1.50 m. To do this, we select the baggage rack element. We rotate this element, as the arrow direction also indicates the filling direction here. We then change the dimensions by specifying that a width of 1500 mm and a depth of 750 mm should be available. We now insert this rack and configure it in detail. We specify that the total height available is, for example, 1,700 mm. This is exactly the height that reaches up to the overhead compartment. There is no distance from the floor to the lowest compartment. The wall thickness on the side is 10 mm, for example. This is a glass wall. The thickness of each shelf is approximately 50 mm. Now we add a compartment. This will subsequently be the lowest luggage compartment. We specify that the width of the shelf that is actually available is 1,480 mm. This is calculated from the 1,500 mm of the floor plan minus the two wall thicknesses of 10 mm each on the left and right. The available height is 85 centimeters, for example. The depth, on the other hand, does not correspond to the full depth of 750 mm, as there may be an electrical duct or ventilation duct at the rear. Therefore, only a depth of 600 mm is available for the bottom compartment. We can also deviate from the width of the rack if the rack does not consist of two vertical side walls but of sloping side walls. In this case, we can specify a different internal width that is greater than the external dimension. In this specific example, we choose 1,700 mm. Here, we must refer to the actual manufacturing data provided during production. Now we select another luggage compartment and specify that only 1,480 mm are available for the upper compartments as well. The next compartment has a height of 400 mm and already has the full depth of 750 mm. If we now add the next height, we see that adding 850 plus 400 mm and a base thickness of 50 mm results in a total height of over 1,700 mm. The rack cannot therefore be stored. By entering 350 mm in the top compartment, we achieve exactly the height of the overhead storage compartment, which remains continuous. Alternatively, we can remove the overhead storage compartment at this position and place the luggage rack higher up. There are a wide variety of design options here. For the vis-a-vis seating area, we add a table, among other things. For reasons of symmetry, we then want to add a corresponding rack on the opposite side. In general, it is recommended to always ensure symmetrical arrangements in vehicles, especially with regard to luggage storage. It is advisable to save your work from time to time so that you don't lose any data and can maintain an overview of the vehicle. The first step is to add a luggage rack to this area. To do this, we can easily adjust the seats here, as the existing space is already suitable. We can either remove both seating areas and insert the luggage rack, or turn one seat around and then remove both seats. In terms of symmetry, this arrangement seems appropriate. We make sure to turn the luggage rack and insert it in the desired position. Due to the arrangement of the seats, there is more space available here, which we can make good use of. The actual available space is 1,800 mm, so we can plan for a rack of approximately 1,700 millimeters. We choose the increased distance of 1,700 millimeters, but we also have to adjust the change dimensions in the interior. In fact, 1680 millimeters are available. At the bottom, there is a greater width due to the adjustment to the seat back lines. We have now inserted 2 luggage racks into the vehicle. Both vehicle layouts can now be evaluated. To start the evaluation, we click on Analysis. And then select Layout Evaluation. Layout evaluation means that individual layouts can be compared or contrasted with each other as part of the evaluation. In the next step, we select our project and one of the carriages we have created, in this case, the one we have just created. We now have the option of using different travel purposes that we created in the project definition for the general region. Examples of this are main travel days in airport traffic, mainly business trips, a classic main travel day without special consideration of the airport, or an annual average value. We can specify that a day with many business trips is compared to a classic main travel day. In the next step, we can select which graphics we want to generate. It is possible to select all graphics or to select specific ones, for example, only those relating to baggage storage, seat usability, and passenger changeover time. With a little practice, you can select the specific graphics you want to look at. We can decide whether we want to compare different layouts in terms of luggage capacity, view a layout for different travel purpose mixes, or compare several layouts with different travel purpose mixes. The same applies to the display of seat usability. For passenger changeover time, we have the option of generating line graphs across the proportion of passengers, showing the cumulative passenger changeover time per person. We can calculate the changeover time for each individual door. Alternatively, different doors can be compared with each other within a layout. We can also always select the same door for comparison between different layouts. We also have the option of comparing different travel purpose mixes and additionally evaluating the time required in the form of a bar chart over a defined number of people. For an overview, we now select all graphs. In the next step, we select the layouts and specify that the upper doors should always be compared, as a door on the upper and lower sides of the carriage provides the same passenger changeover time in a center aisle. Under Advanced Settings, the project settings for this specific evaluation can be adjusted again. We can also decide whether different standing areas should be taken into account. It is also possible to allow only a portion of the passengers to board or alight. For example, 60% when boarding and 40% when alighting. In addition, we can base the analysis on an absolute number of people, depending on standardization requirements or preferences. In this case, however, we leave the default settings and observe the 100% passenger changeover across all passengers. Once all settings have been made, we click on Analysis and let the tool perform the calculation. Depending on the complexity of the layouts and the amount of data to be processed, the evaluation may take varying amounts of time. However, we are usually finished within 10 to 20 seconds. You may have noticed that a download window opened briefly. In this download window, we can now take a closer look at the various layouts and the generated charts. Within the folder provided for this purpose, we see subfolders for luggage storage, seat usability, and passenger changeover time. At the same time, the layouts are displayed again. We will now look at the respective results. First, we will look at luggage storage capacity and see various graphics that visualize luggage storage. Here, we see the stowable luggage versus non-stowable luggage between the two layouts on business travel days or peak travel days. Here we can compare the two different layouts in combination with the different travel days and see that there is a high proportion of non-stowable luggage in layout number 1, especially on peak travel days. This allows you to compare the different areas and layouts with each other. For example, a layout can be viewed specifically for different travel purposes, in this case, business travel and main travel day. We can also look at the same graphics for seat usability. In terms of seat usability, layout number 1 has 86 usable seats on business travel days, but 6 seats are unusable. Layout number 2 has 83 usable seats. On main travel days, only 77 seats are available in both layouts. This means that in layout 1, 15 seats are unusable, while in layout 2, where there are fewer seats due to the luggage racks, 7 seats are still unusable. However, this has not reduced the proportion of seats that are actually usable. In other words, the removal of seats and installation of luggage racks has not reduced the usability of the seats. Here we also see a comparison of the absolute number of available seats and further comparisons based on travel purposes. In the next step, we look at passenger changeover time, both in the cumulative display and using many other graphics. These can, for example, analyze a specific door and compare the two layouts with each other. It becomes clear that passenger changeover time increases significantly in layout 1 without luggage racks, as more people can fit into the vehicle, which further increases the time. Even with a fixed number of passengers, for example 40, there is a noticeable difference in boarding time. The same representation can be used for peak travel days. For alighting passengers, or for the total passenger changeover time for boarding and alighting passengers. In the same step, you can compare the different doors with each other or view the same door in different layouts. Here we can now see the individual doors in terms of boarding time, alighting time, and total changeover time. One example shows the business travel day or the main travel day. These representations are created for all doors. In this display, we compare the different travel purposes with each other, both for disembarking and for the total time. you can see that there are a variety of evaluation options. For example, within Layout 2, the left and right doors can be compared with each other. Since the toilets are located on the left-hand side and there is a slightly longer aisle area, nominally fewer seats are accessible than via the right-hand door. This leads to a difference. The longer aisle area also has a slightly positive effect on passenger changeover time, which can be seen here. This means that a wide variety of evaluation options are available to you. In the next step, we look at the total time, for example the passenger changeover times in comparison for the overall view. In this example, 100 passengers alight and another 100 passengers board. The difference between the left door and the two layouts is already clear here. You always see the boarding time, the alighting time and, at the top, the time for the entire changeover time. Here, the comparison would be between a layout and the two doors below each other. Here, we would have a door in a layout with different travel purposes. This gives you a wide range of comparison options for passenger changeover time. In the settings, you can also specify different values, for example, not 100% but only 60% or 40% passenger changeover. The graphics then refer exactly to these settings. These options can be found in the advanced settings. Now we want to create a train. To do this, we go back to Projects and select the train icon. When creating a train, we can assign a name, for example, Intercity 2 Train 1. You can choose this name as you wish. Since the example is a classic intercity train with a locomotive, it is possible to insert the locomotive symbolically. We can then name the locomotive and subsequently add carriages. To do this, you can select any carriages from the project. In the example, we have only created one carriage, which we will also use. It is designated Carriage 1. To do this, we select Layout Variant 1, which is shown symbolically here. In the next carriage, which we call Carriage 2, we select a layout from Variant 2. We can then add another layout with the number 3 and select layout number 2 again. It is also possible to rotate the layout if the carriage is attached in reverse order. Finally, we attach Carriage 4, also with the same layout as Carriage 1, and can also rotate this layout. The train formation is particularly interesting because passengers can change to the adjacent carriages. In a layout analysis, only the individual vehicle is considered, without taking into account the movements across the carriage transition to adjacent carriages. However, if there is no door, it should be assumed that passengers can move not only to the left but also to the right. Especially in open vehicles with open gangways, regional trains, suburban trains, underground trains, or urban transport, it is often standard practice for passengers to change to another element. In this case, train formation is particularly advantageous. Now we have configured a train that we can also evaluate. To do this, we click on Analysis and select Train Evaluation. We select the project, specify two travel purposes and determine what information we want to receive, for example, only a comparison of passenger changeover times for all passengers together. We can also specify that all doors along the train should be taken into account. In addition, different travel purposes can be compared with each other. It is also possible to select different trains and compare any doors with each other. This option is controlled by the last setting. Furthermore, cumulative settings can be used, which we are not doing in this example. The same comparison options are available for luggage storage and seat usability. We now select the trains we want to analyze. In this specific case, only one train has been created so far. For passenger exchange, we select the upper doors, as the lower doors in the center will provide the same value. With regard to luggage storage and seat usability, it is important to select the areas for which the evaluations are to be carried out. In this case, these are the for individual carriages. The advanced settings offer the same options as before for the layout evaluation. We then click on Analysis again, which displays the download field. The same subfolders are available again. Luggage evaluation, seat usability, passenger changeover time. In addition, train order shows the arrangement of the carriages, which is symbolically represented as in a carriage position display. For example, we can view the different areas along the train in terms of luggage storage. As already noted, layouts with luggage racks have significantly better luggage storage capacity. We can also compare the individual areas depending on the different travel purposes. Here we see the arrangement of the carriages in the order carriage 4, carriage 3, carriage 2, carriage 1. The same applies to seat usability. Here, too, the same graphical representations as before are available, now relating to the respective train or the selection options made. For passenger changeover times, we have only selected the total graphics. However, there are significant differences along the entire train. Carriages with limited luggage storage or only overhead racks have significantly longer passenger changeover times than carriages with good luggage storage. There is also a difference between the doors. Doors on the toilet side have a slightly faster passenger changeover time. This can be seen throughout the entire train on both a business travel day and a peak travel day. Various comparison options are available. For example, travel purposes for individual carriages and different doors. For the overall and total presentation, it makes sense to repeat the evaluation with different values for passengers boarding and alighting. You can either specify concrete numbers, for example, 40 people, 50 people, or a utilization value below 100% to calculate the passenger changeover time. A 100% utilization means that all passengers alight and the same number board again. This was a quick overview of how to use the software. You can edit different projects via the projects list. You can select different carriages, edit them and create layouts. You can assemble trains from different layouts or carriages, and have them evaluated for individual layouts or for entire trains. The results always provide you with passenger changeover time, luggage storage capacity and seat usability. Luggage storage capacity and seat usability mainly refer to vehicles in the long-distance sector. For regional and urban public transport, these graphics are only displayed to a limited extent or not at all, as they are considered less relevant in these areas. Passenger transfer times are displayed for all travel purposes. For additional details on the individual steps, there are separate training videos that explain all options in detail.